Today we have to figure out how much gravel we need to order for our driveway. So the basic skills you're going to need for this are, again, some high school geometry. We're going to talk a lot about areas and some more advanced techniques for calculating areas of irregular shapes. So the first ones you're going to need basically three shapes to be able to figure out how to do everything. There's the rectangle. I think everyone knows how to do this. There's width of A and length of B. The area is just A times B. There is a circle with a radius. I like to work in terms of diameter, D. So the most famous formula is pi r squared, but another one that I find more useful is actually 1/4 pi diameter squared. The last one that's going to be, well, I guess there's triangles, which are important too. So if you have a triangle, you have base and height, and the area is just half base times height. So these are the three basic ones. The next one that's going to be somewhat important is the trapezoid. And a trapezoid is just a shape with two parallel edges. So this edge is parallel to this edge, and then two irregular edges. It doesn't have to be quite symmetrical like this about the center, but there's, we'll say, width 1, width 2, and then there's the height. And the area of the shape is just the average of the two widths. So half width 1 plus width 2, and then the height times the height. So not super complex. And like I said, you can have a really lopsided trapezoid. And this formula works out the same way. So that's areas. Now we gotta convert these areas into volumes, and most of the shapes we're working with in construction are just what are called prisms. So it's basically you take a shape like a square or rectangle and you stretch it out. So as you see, we have this rectangle here, and then we stretched it out into a 3D shape. So really calculating the volume for prisms is easy. You just have the area of that shape that you stretched out and then how far you stretched it out. So say we stretched it out for length L, the volume is just area times length. And in the case of a rectangle, say we have side A, B, and length, then the volume is just A times B times length. So let's talk a little bit about our driveway specifically. So if we look at our driveway from the side, on a first approximation, we can kind of consider it to be a kind of like a triangle. So there's the road bed here, and then there's the slope of the bank of the road that goes down into our drainage ditch, and then there's the slope of our driveway, and then this portion is what's going to end up getting filled in with gravel. And if you look back to our other videos, you see that we have our culvert here. It's just a circle. So road, and then this area in here is what we have to fill. So even though this triangle doesn't look like our other triangle, the calculation of area is the same. It's really just half base times height. So what I did is I went out to the site and I put a stake here, and I put a stake here, and I ran a string line that goes from this stake to this stake, and that's how I got this line here. And then I went with a tape measure and measured the height from the ground to the string line. So I have this measurement, which is my height, and I've got this measurement with a 300-foot tape, which is my base. And so my area is half base times height. So let's put some real numbers to this. I've got my my actual measurements here in my notebook. So it's a little messy, but as you can see, my driveway is 60 feet long. My driveway is 60 feet long and 25 inches deep. So let's take that 60-foot length and that 25-inch depth and see what we get there. Let me bookmark that so I don't lose it. So half, 60 feet, and now the height's in inches, 25 inches, so we gotta convert that to feet really quick. So 25 inches, 12 divide, gives me 2.08 feet. So that gives us an area of 2.08 times 60 divided by 2. So that's 62.5 square feet. And now, just like with our other prisms, we gotta stretch the shape out by the width of the driveway. And I'm planning on a 16-foot wide driveway at this point. So the volume is just the area times 16 feet. So that's 62.5 square feet times 16. So 16 times, wow, that actually comes out to 1,000 even. So now that we know the volume of my driveway, we need to calculate how many tons of gravel we need to order. So we have to use the density to convert from this volume to a weight. So what I'm gonna be ordering is 1.5 inches minus. The density of this gravel is 150 pounds per cubic foot. So if I multiply that by the 1,000 cubic feet I need, I get 150,123 lb. And everyone in the industry works in tons, so we just divide that by 2,000. And that's 75 tons. So overall, I think this is not the most accurate way to do this. I think what I'm going to do is, instead of approximating my driveway as a triangle, I'm going to get a more realistic shape, because the more realistic shape looks something more like this. And so as you can tell, like, this is all gravel that I estimated that I need, that I don't really need. So we're gonna try this approximation next and see if we get a better result. So, and then what I did is every 5 feet, I took a depth measurement. And so I took my tape measure and I measured from that string line down to the ground. And so now how I can actually get the area of this complex shape is by approximating the ground as trapezoids. So this first shape is actually a triangle, right? We have a leg, and then the hypotenuse. But this second shape is actually a trapezoid. And remember I said a trapezoid is just a shape with 2 parallel sides, and this is 2 parallel sides and a height. So I'm gonna go through and draw on the rest of these trapezoids. So as you can see, it's not a perfect approximation. There are little gaps that I miss, and sometimes I overestimate, but it's a lot better approximation than a triangle would be. So let's, basically we're gonna calculate the area of one of these little segments, and then we're gonna calculate the area of the other segment, and we're gonna do that for each of the segments, and then add all those areas up, and that'll give us the total area of the shape. So I'm gonna show you how to do a couple segments, and then I'll probably cut to a time lapse, and I'll do the rest of the calculations for all of them, and then I'll come back and we'll add them all together. Let's look at my notebook really quick, and I'll show you what I actually recorded for those measurements. So as you can see, at 0 feet, I measured 0 inches, obviously, because it's a triangle. At 5 feet, I measured 24 inches. At 10 feet, I measured 22.5 inches. At 15 feet, and so on and so on and so on until we get to the very end of my driveway, which is 60 feet long. So, as an example, we'll say we're measuring this one, let's say the 15-foot marker and the 20-foot marker. So at 15 feet, my depth was 19 inches, and at 20 feet, my depth was 16 inches. Let's add one more at the 25-foot marker, because we'll need that in a minute. At 25 feet, I'm at 11.5 inches. So we'll actually pop this, this trapezoid out of the drawing, just so it's a little easier to see what's going on here. And if you actually look at my measurements, this side is actually deeper than the other side. So my first measurement was at 15 feet. My second measurement was at 20 feet. So that means this, this trapezoid is 5 feet in height. So that's their height. And then one side of our trapezoid is 19 inches. And the other side is 16 inches. So we can't mix units here, so we're going to convert those back to feet. So 19 divided by 12 is 1.58 feet. And 16 divided by 12 is 1.33 feet. So if you remember, the area of a trapezoid is the average of the two parallel sides times the depth, so times 5 feet. So if we run this calculation really quick, the area of that particular trapezoid is 7.27 square feet. So there's actually another trapezoid that's like right next to it, and it's actually sharing an edge with the trapezoid we just calculated. So I'm gonna draw that right next to it. Again, it's 5 feet, and then this length here is 11.5 inches. So that's really almost a foot. So 11.5, 12, divide, so it's 0.95 feet. 96, because it's an 8, so we gotta round up. So the area of that second trapezoid is again, the average of the two sides. So if you notice, it shares the sides, so this measurement's the same. So we'll do that math real quick. And the second trapezoid's a little smaller, and it's 5.72 feet. So now we can actually add those two trapezoids together and get the total area of this slightly more complex shape now. And the total area is 12.99 square feet. So I've done, like I said, measurements every 5 feet from 0 to 60 feet. So I've got a long way to go, and I'm just gonna run through this calculations really quick. We got to subtract off the area for the 3 culverts. So let's do that really quick. So 1 foot in diameter squared times 1/4 times pi times 3 equals. So that gives us a total area minus the area of the culverts. Gives us 54.72 square feet. So if we go ahead and multiply by 16 foot to get our volume, we get 875.52 cubic feet. And if we again multiply by the density of 1.5 inch minus, which is 150 pounds per cubic foot, we get 131,000 pounds. Sometimes that's referred to as kip, which is 1,000 pounds. We'll divide that by 2,000 to get tons. And we still get 65.6 tons. So our previous answer, based on the triangle method, was 75 tons. Our more accurate method is 65.6 tons. So not that big of a difference, but that's how much gravel we need.